Advanced Algebra Chapter 13, Lesson 3, and we want to look at one application of radian measure. We began by looking at the problem that there's no connection between degrees and then the circle itself as far as units go. But by developing a radian measure, we know then that the length of the arc that is intercepted by the two radii is the exact same length as the radii themselves. So if we have 1 radian, then we know that the measure of the arc is equal to the length of the radius, which leads to a formula. And I'm going to discuss that formula again from the pre-calculus videos. This will be the one application that we'll look at in this lesson. The second thing we wanted to talk about before we move further is the fact that since a central angle of 1 radian always will intercept an arc that's 1 radius in length, then it follows that a central angle of any number of radians in a circle with a radius r will intercept an arc that's equal to that number of radians times the length of the radius. So what that does is that gives us this little equation where s is the length of the arc on the circle, r will be the radius of the circle, and then theta will be the measure of the angle. Now the only caveat here is that this angle must be in radians. So if you're given the measure of the angle in degrees, you're going to have to use your unit multiplier and convert it before you can find the length of the arc. So really quickly, let me give you a picture of what that is. So the application of that would be, let's say we have this arc here that's equal, or this radius that's 4, and let's say that this angle we know is 3 pi radians, 3 pi over 4 radians. What would be the length of the arc? So what I'm looking for is the length from here. If I was to walk along the arc, of course I could walk, I could stay on the line there and walk. How far would that length be? So that would be the s in our equation. So s, the length of that arc, is equal to theta, that's the measure of the angle in radians, which this is. So that would be 3 pi over 4 times the radius, which in this case is 4. So if I multiply these together, these reduce, so the length of the arc is 3 pi units in length. So you can see from the example, it's a pretty simple formula. S, which is the length of the arc, is equal to the measure of the angle in radians, theta, times the radius. And a simple application of radian measure.